Over on the right, we see an image of a cone. And here we're walking through the steps to find the surface area of the cone. The formula for surface area is on the bottom left, where you see we need to substitute in the radius for r and the slant height for L. So first, let's find the radius. The radius is the distance from the center of a circle to the edge. And so we're going to look at the base of the cone here. I don't see the radius, but I do see they're giving us the diameter. The diameter is the distance from one side of the circle through the center to the other side of the circle. Again, the radius is the distance from the center to the edge. So the radius is always half of the diameter. So in this case, the radius is 18. Now let's find the slant height. The slant height is the distance from the apex, the tip of the cone, down to the edge. And we use the variable L to represent the slant height. So in order to calculate the length of L, what we need to do is find a right triangle within this cone. If we have a right triangle and we know two side lengths, but not the third, we can use the Pythagorean theorem to find that missing side length. Do you see a right triangle here where we know two of the side distances, but not the third? This distance represented by the purple line is the distance from the apex straight down to the center of the cone, and that's 16 meters. And then the red line is the distance from that center of the cone over to the edge of the circle. And that is our radius. Do you remember what our radius is? Remember the distance all the way across the cone, the base of the cone, that circle, is 36. And so only to the center of the cone is half of that. That's 18. So here we go. We have a right triangle where we know two side lengths but not the third. So we can use the Pythagorean theorem to find that missing side length. So the Pythagorean theorem is a squared plus b squared equals c squared, where a and b are the legs. They are the two side lengths that form the right angle. So it doesn't matter which of these we designate as A and which as B. Let's say 18 is our A and 16 is our B. And then the other side is always C. It's called the hypotenuse. It's the longest side of our triangle, and it's always directly across from our right angle. So let's substitute those numbers into the formula. Now, in order to solve for L, we first need to simplify both sides. On the left side, we can put in our calculator and see what 18 squared is. It's 324. And what 16 squared is. It's 256. Now let's add the left side. Then remember, how do we undo the square to get L by itself? The inverse of squaring is square root. So if we square root this side, it cancels out that square. So we need to take the square root of 580 as well. And when I do that, I'm going to round to the nearest tenth, I get 24.1. Now that I know the radius and the slant height, I can substitute these into the formula. I'm also going to substitute in 3.14 for pi. So instead of pi, I'm going to put 3.14 and then times the radius squared, so times 18 squared, and then plus pi 3.14 times the radius of 18, and then times the slant height of 24.1. Now, in order to simplify, you want to multiply these together first and then add. When I add them together, I get 1,689.3. And my label would be meters squared, because the units for area is always squared.